13.3 is on higher order derivatives. Higher order derivatives. That means second derivative, third derivative, fourth derivative, however far you can go. And you can see different notation for that, just like you could for first derivatives. But most often, I'll use this, and you'll see that most often in the book or on the test. F double prime of x. And you could have F triple prime to the fourth, whatever. And if it gets tedious writing little marks, you can have F and then a 4 up there, which you'll see a little bit later. So just know that we're going to practice that. And all you're going to do, you get the first derivative, you just repeat the process. And you'll end up with the second derivative. And keep going. Okay? So that won't be difficult. And because we're talking about higher order derivatives, we're going to throw in again about that position function. When you have a position function, it's written as s of t. Well, s prime of t is the first derivative, that's velocity. S double prime is the second derivative, that's acceleration. It's really helpful in physics problems if you have to take any more physics or calculus. How many of you, this is the last math you have to take? Oh, amen to that, right? Okay, awesome. Awesome. How many people have to take a little bit more? Okay. Are you guys engineering majors or business majors? What do you got to take, stats or?
Well, then we have finance too.
Finance.
Level finance.
Yeah, but that's okay. You can do that.
No, it's not.
No, it's not.
No, it's not. It's not available.
It's bad.
It's bad.
Well, stats is my least favorite math. I know Gail is wonderful at it, but it's my least favorite thing. Doesn't. Of course, this might be your least favorite. I don't know. Okay. All right. So we'll do that. Now, the new stuff. What we're going to use the second derivative for is to find out a little bit more about the graph. Remember yesterday I said that back in the old days, we couldn't look at it on the calculator, so we had to use things to determine what the graph looked like. Well, we're going to find whether the graph's turning up or down. That's concavity. You kind of think about a bowl or a cup. Concave up, it's like a cup. And concave down is just pointing down. It should be easy to remember. And concave up is when the second derivative is positive or greater than 0. It's down when the second derivative is negative. Okay? So we're going to do that same kind of test thing that we did for increase and decrease. And when it's positive, we're going to know it's concave up. When it's negative, we're going to know it's concave down. Okay? We found critical numbers yesterday. That was where the first derivative was equal to 0. When you take the second derivative and set it equal to 0, you're going to find a point of inflection where it turns from being concave down to concave up. That's a point of inflection. So you're going to do the same thing we did yesterday. You're going to find the second derivative, set it equal to 0. That's going to be your point of inflection. And then we're going to draw that little line and do the intervals and do the test. It's the same thing. Okay? So here's the second derivative test, kind of like the first derivative test. Where it's positive, f of c is a relative min. That's kind of the opposite of what we had with increase, decrease, right? Think about it. The first derivatives test said if you were increasing and then you were decreasing, then that c was a max. This is saying if the second derivative is positive, then f of c is a min. It's kind of opposite in your head, or should be. And if it's less than 0, then it's a max. Okay?
Is there a continuation of that? Do you go on to a third derivative?
As far as testing, as far as finding, I mean, you can find third derivatives, but as far as analyzing a graph, no.
You can create a wave.
It would be another graph, certainly, but it's not going to tell you.
It'll get alternated like with exponents.
It just goes down one level. In other words, if you start out with a cubic then the first derivative is a quadratic. So you had this graph, and then the first derivative is this graph, and then the third derivative would be a straight line. So you just come down 1 degree. I don't know if that answers your question. All right, any questions about the notes? Okay. All right, let's look at the problems that you guys have. Okay, so in your problem set in 13.3, the first one says find f prime of x, f double prime of x, and then f double prime of 0 and of 6. So this is easy. This is just taking a derivative twice. So you start out with 2x cubed minus 3x squared plus 3x plus 3. We're going to take the derivative of that. Just plain old polynomial, no quotient rule, no nothing, easy. 6x squared minus 6x plus 3. To find the second derivative, you just keep going. That one becomes 12x minus 6. Does that make sense? You're just taking the derivative again. Okay? Then if you have to find f double prime of a number, it means you plug that number into that derivative. If you put in 0 for x, you're left with negative 6. If you put in 6 for x, you get 72 minus 6, which is 66. So we're just finding whichever derivative they ask us to find, and then if they say do it for a number, we're plugging in that number. Okay? Questions on that one? Can I move it up? I'm still writing. Number 2 is the same thing. 4x to the 4th minus 2x cubed minus 4x squared plus 3. You might, instead of just writing down what's up there, try to do those two derivatives without looking up there, and then make sure you're right. Take the first two derivatives, and then find f double prime of 0 and f double prime of 6. Anybody need to borrow a calculator? Drew, do you? Everybody doing okay? Just finding those? That's pretty much, it's easy. Just taking the derivative and plugging in. And then we hit 3. All right. 3 is a quotient. So if you're going to have to do the second derivative, you're going to end up taking that, doing the quotient twice. Okay? So remember that it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. I didn't write out as a road map. I just wrote it out taking the derivative where I needed to. This is the derivative of the top, and this is the derivative of the bottom. Okay?
Barnes,
Yes.
on the test, you had a lot of like just x's. Is the derivative of x just 1?
Yes.
Okay.
Yeah. Because when you think about it, if it's x to the 1,
Right.
1 comes in the front, that 1 goes to a 0, x to the 0 is 1, so 1 times 1 is 1. So any derivative of any x, single x, is 1. Okay? All right, so here we just combined. We did the multiplication there. 2x times 9 is 18x. 2x times x is 2x squared. And there's a minus x squared there. So that simplifies to 2x squared minus x squared just gives you 1x squared, that's there, plus 18x over 9 plus x squared. Does that make sense? Okay, so that's pretty basic. We've done quotient rule. You should be able to do that. Then to get the second derivative, we got to do it all over again with this quotient, which is a little bit, it's just tedious. It's not that hard. It's just a lot of stuff. Okay, so we did the same thing. Bottom times the derivative of the top minus the top times, and this is the derivative of the bottom. That's the calculus part of it. The rest is algebra. So it's making sure that you can multiply and find like terms and that sort of thing. So I multiplied out here. I've left that like that. I have 9 plus x to the fourth. I didn't go further at that point. This is something you need to begin to recognize, that when you see this term, 9 plus x is there squared, it's there, and it's here, that more than likely we can do some factoring and we can do some canceling out. So that's what I did. I took 9 plus x and factored it out and said, okay, if I take 9 plus x out of this guy, okay, I'm just looking here, then one of those is left, 9 plus x, and that's left. Everybody good with that? If I take it out of this piece, then the 9 plus x is gone, and I'm just left with this. So that's there. Okay, we good? Then I did this multiplication, and lo and behold, some things canceled out, which I've marked in yellow. There's a 2x squared, there's a minus 2x squared. There's a 36x, there's a minus 36x. And the only thing that was left is going to be the 162. This 9 plus x and 9 plus x to the fourth, what happens? That one goes away. I change this one to 9 plus x to the third. It's like I took one of them out, which leaves me with the second derivative of 162 over 9 plus x to the third. That is just algebra, not the calculus. It's the part that does people in. So be careful with that. You've got these notes will be posted, so when you're practicing or when you're looking, you're doing your homework, follow that format. That's going to help you. Okay, so then it asked you to find f double prime of 0 and f double prime of 8. If you plug 0 there, you have 162 over 9 cubed. You can do that on the calculator. Probably get a decimal, see if it'll turn into 2/9. Somebody do that for me and let me know. Does it? Okay. So, feel free to use your calculator there, but the answer they're going to want in Math Lab is a fraction. So be sure that you remember that. Why is that doing that? It's erasing. What is up with that? Stop. Okay. All right. Okay. Giving me a hard time. It's disappearing instead of... Okay, maybe if I write slow. All right, f double prime of 8. Can you get that one on the calculator? Doing that and changing it to a fraction. Meg, did you do that one? Yeah, you can get that one? Okay. All right, so any questions on that one? Okay. All right. Number 4. The first part of that's not too bad. It's got e to the x in there, and remember that when we have e to the x or e to the u, there's that rule for that, okay? The derivative of that is the original 2e to the negative x to the fourth times the derivative of that thing. What's the derivative of negative x to the fourth? Because it's sitting right there. Hopefully you can read that out. Negative 4x cubed. Okay? So don't forget to do that. All right? That rule is e to the u. You get e to the u times u prime. That's the rule for that. Okay? So that gives you your first derivative, because I just multiplied the 2 and the negative 4 and got negative 8x cubed e to the negative x to the fourth. So that's your first derivative. Okay? But then to go to the second derivative, now what do we have? We have a product. Okay? You have a product. I did write the road map out for that guy. It's the first one times the derivative of the second one plus the second one times the derivative of the first one. Okay? So the only place I'm taking derivatives is where I have yellow. Okay? So you have negative 8x cubed times, and we're going to do the derivative of e to the negative x to the fourth. There's the original, there's the derivative of the exponent. That's what we're going to multiply together. Over here we have that times the derivative of negative 8x cubed is negative 24x squared. Okay? And those are things that we did on the last test. So we should know how to do those. That's a theory though. Okay. All right. So here, all that I did was multiply negative 8 times negative 4, got a positive 32. Where did I get x to the 6th? Okay, you got here x cubed and here x cubed, so when you multiply those two things, you add the exponents. So that's 32 x to the 6th e to the negative x to the 4th. Minus, I just put the 24x squared in front, e to the negative x to the 4th. When you get that far, you want to look at it and say, what can I factor out? Out of 32 and 24, you can take out 8. You can take out x squared. Remember, you take the smallest exponent, so 8x squared, and then I can take out this, e to the negative x to the 4th. And you're left with 4x to the 4th minus 3. And that's your second derivative. F double prime of 0, that's not too bad, because if you put 0 there, you're going to be multiplying, you get 0. So that one's 0. For the other one, F double prime of 1, because you've got E and all of that, sometimes it's easier to do it on the calculator. I don't know if you guys can see, that's the way to put it in. Let me make this really big for a minute. Where did it go? Okay, right here is how to put it in the calculator. Maybe practice that. 8 times 1 times e to the, and I plugged in negative 1 to the 4th, times 4 minus 3. I was just plugging in 1 everywhere there was an x, but put it in there, and you should get 2.9430. Just double check that you can do that kind of thing, because that'll be the easiest way for you to do it on the calculator. And you're just, what you're doing is plugging in 1 here and here. Everybody okay getting that? We'll go back to normal.
Is the E button on the calculator second?
Second LN. Yeah, the natural log button, ln, it's by the log. So if you do second and ln, you'll get e with a caret. All right. Any other questions about that? That's a good question. Thank you. So, we good? All right, number 5. Does number 5 just ask for 4 derivatives on your paper? Does it say find the first, second, third, and fourth derivative? So third and fourth? Okay, well, to get the third and fourth, we have to do the first and second. So here's your answers that you would have to fill in. But this one's not bad. It's just polynomial, so it's just doing it over and over again. Whoops. Okay. So there's the second, the third, and the fourth, and you should be able to do those. That will not be bad. Bless you. Okay. All right, so that's really the higher order derivative thing. That's what we're working on for that part. And then we start getting into where are things doing what. Number 6 gives you this kind of graph. I think it got moved. I don't think it's up there, is it? I think I must, when I inserted that calculator screen, which I did after the fact, I think it pushed things. Sorry. Okay. So it does something like that. And it has a point there, and that's at 2, is that negative 46 thirds. I don't know what that little thing is that I have written there, but we'll get rid of him. Oh, I guess we did. Okay, there we go. All right, so the question says, find the intervals where this function is concave up or concave down. Find any inflection points. You're not having to do any calculus on this one. You're just examining to kind of get a feel for what we're looking at. So if you think about it, it gave you this point. With inflection points and where it changes concavity, sometimes that's kind of vague. But in this one, when they give you a point, do you see that it's concave down to there, and then it's concave up? We have a cup here, it's down here. There's a lot of points right along there that you could say that's a point of inflection, but they gave you the point. Okay, so the point of inflection is x equals 2, and it wants an ordered pair. So point of inflection, you're just gonna write that. That's the first answer. And then choose the correct answer. So where is this thing concave down? From what to what? This is going on forever. It's down from what to what?
Negative infinity to 2.
Yes, negative infinity to 2. Did everybody see that? Because that's where we're saying that it's changing. It is concave up from what to what? 2 to infinity. All right, so which choice is that? Is that C? Okay. All right, so that one's just examining. Did I do it right?
No, it should be concave. It should be A.
Oh, I just didn't even read the words. Sorry. And somebody said right. Was that you? Yeah, you got to catch me when I do those things. I can't have people agreeing with me when I'm wrong. Okay. So what was it, A? Yeah. Okay. I just didn't read it. Okay. Everybody good with that? All right. Then we're going to get to where we're doing the test, number 7. Okay. It says find the open intervals where it's concave up, where it's concave down. So same idea. We've got to get the second derivative. So this is polynomial. It's not bad to take the derivative. You need to do the first derivative and then the second derivative, okay? And you're going to set the second derivative equal to 0. Do what? Okay. So when you set the second derivative equal to 0, you're actually getting a possible point of inflection. If there's no change, if it doesn't go from down to up or up to down, then there's no change in inflection. So you have to test it before you actually know that it is the point of inflection. But it's a possible one. Does everybody see where we got x equals 3? Take that second derivative, set it equal to 0, solve for x. Okay. And then you're going to make your chart, just like we did for the first derivative. Draw you a line, draw a vertical line for any possible point of inflection. So here we have x equals 3. On the right of it, we have x is greater than 3, and we have x is less than 3. Now, if you want to help yourself out and write those intervals the way the answers are going to be on this one, because they're going to want it with infinity, this is also 3 to infinity, and this one is negative infinity to 3. So either way, on the test for me, I would take either one. I mean, the interval is the same. Either you're saying x is greater than 3 or 3 to infinity. So either way, you could write that interval. Then you need to test a point, something less than 3. Well, 0 is easy, so I chose 0. Greater than 3, I don't want to go too big. I just chose 4. And you are plugging it in where? Second derivative. F double prime of 0, F double prime of 4. So you're plugging it in right here. If you put in 0 there, you get a positive 54, so positive. If you plug in 4, you get a negative number, so negative. Once you find that out, then your answer's there for you. Where is it concave up? Over here, from negative infinity to 3. Where is it concave down? 3 to infinity. And those are the answers. So if you draw that line and write your intervals, and we're assuming you're going to do the algebra right, and you're going to get the plus and minus right, then you'll have your answers. And it won't be that bad. Questions on doing that? When we hit section 13.4, what we're going to do is pull all this together and say, okay, we're going to take a function, we're not going to throw it in the calculator, and we're going to decide what it looks like, and we're going to sketch it knowing where's it increase, where's the concavity, all of those things. So that's what we're headed to. Okay. This one is, again, a quotient. And I've done the first derivative. I want you guys to try the second derivative after you write down the first derivative. That'll be good practice for us. Bottom times the derivative of the top, and remember that the derivative of a constant is 0, minus the top times the derivative of the bottom, over the bottom squared. Okay? So after you get that written, try to get the second derivative. Is that what you got? Yeah. So getting the same thing wasn't good? Okay, I put it up there. See if what you've got somewhat matches it. Taylor, did you get it? Good job. So if you didn't get it, check your algebra, see where you went awry. I never use that word. I don't know where that came from. Did you find where you guys went wrong? Oh, yeah. But now you'll know. You won't make that mistake again. Okay. Any questions on that? All right, then you had to take this thing and set it equal to 0. And what happens to the bottom when you set it equal to 0? It multiplies to the other side, goes to 0, so you really have the top. Set it equal to 0, and it actually equals 9. It's a possible point of inflection. And we draw our little chart. Less than 9, greater than 9. Test 0, test 10. And you get a plus and a minus, you should. And you'll find where it's concave up is negative infinity to 9. And concave down from 9 to infinity. So it's really very much like the first derivative things that we were doing for increase and decrease. When we get to the review, I'm going to remind you, if the question says increase, decrease, in your head you have to think first derivative. If it says concavity, second derivative. Okay, that's the key there. All right?
Why did the denominator go away?
When you set this whole thing equal to 0, so you did that, first thing you'd want to do is get rid of this denominator, so you would multiply both sides by this denominator. It'll cancel there, and if you multiply it by 0, it goes away. Okay. All right, questions? Anybody? Okay. Let's take about a 5 or 10 minute break. Let's stretch a little bit. We'll come back and we'll do 13.4, and then we'll go to the lab. Okay? 5 or 10 minutes.